Okay, so I know we're not doing official learning, but I can't sit here and do nothing. So I figured the least I could do was go over the study guide that we had like a week and a half ago now. So I'm going to go over this as kind of a review to the exponents. If you have other questions though, please let me know. Hopefully you have your study guide in front of you. If you don't, let me know. I will repost it, or I'll post it to Google Classroom. But this would be so much easier if I had a document camera. I'm kind of working around my tripod here. So this says write each expression using a single exponent. And so all this means is 1 times all of this. Remember, 1 times anything is anything. So I saw a lot of people with some really random answers. Remember, this just means 1 times this, and this. So you put this in your parentheses. And then you say, well, how many of them are there? 1, 2, 3, 4, 5. -2 to the 5th. Remember that fractions and negatives need to be in parentheses, because if the negative's not inside the parentheses, it can change the answer. So that's that one. Super simple, right? 1, 2, 3, 4, 5. So it's -2 to the 5th. This one you can do 2 different ways. So we have parentheses. So there's a set of 3 in there. And then this is saying there's 4 sets of those 3. So you can either go 1/5 in parentheses and say, okay, what are 4 sets of 3? Well, that's 12, right? 3 plus 3 plus 3 plus 3 is 12. You can leave it like that. Or, remember, this also means 1 to the 12th over 5 to the 12th. 1 to the anything is just 1, so it's 1 over 5 to the 12th, which we know you can flip to a negative exponent. Remember, the negative exponent and the fraction interchange. Okay? This one is saying there are 7 4s inside the parentheses, and then there's 2 sets of those 7. So if you can't remember the rule, you could totally break this down and go 4 times 4, 7 times. 1, 2, 3, 4, 5, 6, 7. Okay, that's 1 set of them. That's the inside. And now we need 2 sets of them. So you could do it again. And then count them. There's 14 of them. So it's 4 to the 14th. Okay. Okay, remember, now a negative exponent shoots these down to the bottom, right? Makes it a fraction. So it's 1 over 6 to the 9th times 6 squared. So we have 2 6s on the top and 9 6s on the bottom. If you can't remember how to do that, put the 2 6s on the top and the 9 6s on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, now what can we do? We can cancel out these 2. Leaves us with a 1 on the top. 1 over 1, 2, 3, 4, 5, 6, 7. 6 to the 7th, which equals 6 to the -7, right? Because the fractions can flip. Okay? Same thing here. You can write out all 9 of the 3's and all 6 of the 3's. You can take a shortcut and say, well, I know that there's 6 3's on the bottom, so now I'm going to be able to cancel out 6 3's on the top. Well, how many more 3's on the top do I need to make 9? 3 of them, right? Whoops, that's supposed to be a 3. So we've got 9 total on the top, 6 on the bottom. We cancel out the 6, and we're left with 3 to the 3rd. Okay? All right. If we move over here, remember 1 times anything is anything. So this is just 4 to the 1, 2, 3. There's 3 4s. Okay, this one, you can take a shortcut or you can write it all out. There's 2 7s in the middle of the parentheses. And now there's 4 sets of these 2. Well, what makes 4 sets of 2? That'd be 7 to the 8th, right? Because 4 sets of 2 is 8, right? 2, 2, 2, 2 is 2, 4, 6, 8. See? All right. This one, we've got 2 10s, 0 10s, and 4 10s. Well, how many is that? 6 10s. Remember, this just equals 1. So 1 times anything is anything, right? We've got 10 times 10 times 0 10s times 4 10s. 1, 2, 3, 4, 5, 6. This one's a tricky one because the negative's on the bottom. When we have a negative on the top, it makes the base shoot down to the bottom. Well, when it's on the bottom, it shoots it up to the top. So that means these 2 are going to shoot up to the top. So now we have 5 15s on the top, and we're going to shoot these 2 15s to the top. Well, that means we have 7 15s total. Okay. Okay, and then this one means we have 3 5s and 7 5s. That's 10 5s, right? 5 times 5 times 5 for this, and then you put 7 more here, so it's 10 total. All right, and then when we evaluate the expression, that means 2 times 2 times 2 times 2, right? And that equals 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Okay? Now 6 to the negative third. Remember, that changes it to a fraction, right? It's 1 over 6 cubed. You get rid of that negative. It flops it down to the bottom and makes it positive. So this actually means 1 over 6 times 1 over 6 times 1 over 6. So 1 over 6 times 6 is 36. 36 times 6, we do over here. 6 times 6 is 36. 6 times 3 is 18. 19, 20, 21. So 216. So 1 over 216. Okay. This one, same thing. 1/5 times 1/5 times 1/5. Okay, this is just this cubed. You didn't have to flip anything. There's no negatives. So 1 times 1 times 1 is 1. 5 times 5 is 25. 25 times 5 is 125. So 1 over 125. Okay, select all the expressions that are equal to 2 to the 6th. Well, let's do them out. This is 2 times 2. This is 2 times 2 times 2. How many 2's are there? 5, not 6, so not that one. Now this one is 2 times 2. On the inside, we have 3 sets of those. So 2, 4, 6. That one works. All right, now this one, if you know the rule, you know that we multiply these, just like we did here, 2 times 3. And -2 times -3 makes a positive 6. So we know this is going to work. But if you can't remember the rule, we know that this is 1 over 2 times 1 over 2 on the inside because it's negative, right? And then we have -3 sets of them. So it's going to shoot those right back up to the top. I know that's confusing, but it's going to make these 3 sets flip back over. So this one does work. If you wanted to, you can turn this big one into a fraction. So it's going to be, on the inside, it's 1/2 times 1/2. And then if you turn it into a negative cubed, it's over a fraction. And then you got to do it 3 times. And if you were to do it out into your keep change flip, you would end up with 2 to the 6th. All right, same thing here. So if these flip to the bottom and these flip to the top. So now we have 11 2's on the top and we have 5 2's on the bottom. Well, if I cancel out 5 of the 2's, how many are left? 6 of them, right? Because if we take 5 out of the 11, there's 6 left. So this one works. Okay. Now this one, let's do some canceling before we do some adding here. We've got 9 on the bottom. Well, that means I can take out all of these 8, right? And I can still take 1 out of here. Right? So 8 plus 1 from here is 9 of them. So we cancel the 9 and we're left with 2 to the 6th. So this one works. All right. Then we've got 2 to the negative 6th. Let's make sure we can still see here. All right. 1 over 2 to the 6th. You need to know that this rule means this. You don't need to do any work for that. You just need to know that that's how it works. Okay? So then we have 1 over 2 to the 3rd times 1 over 2 to the 3rd. So that's 1 over 2, 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 1 over 2. So hello, 1 over 2 to the 6th, which is the same as 2 to the negative 6. So that one works. Negative 6 times negative 6. Okay, this tricked some people. It doesn't mean there's 2 negative 6's. It means there's negative 6 2's. This is equal to 36, which is not equal to this. So that does not work. Okay. Now this one equals, we'll put negative 2 on the inside. 1, 2, 3, 4, 5, 6. Negative 2 to the 6th. That is not equal. Negative 2 to the 6th is not the same as 2 to the negative 6th. Okay? Now this one, if you remember the rule that you're supposed to add these together, means 4 plus a negative 10, which if we do that, it's 4 plus a negative 10 plus a negative means you're subtracting. So 4 minus 10 is 2 to the negative 6. So that works. But if you don't remember the rule, you know that there's 4 2's on the top. This shoots these 10 down to the bottom. So we've got 2, 2, 2, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we cancel out these 4. You're left with 1 over 2 to the 1, 2, 3, 4, 5, 6. Okay? Which is equal to 2 to the negative 6. So this one works. Okay? Okay, place a number in each box so that each equation is true and each equation has at least one negative number. Most people did not read instructions on this one. We need 3 to the something times 3 to the something is going to equal 3 to the 0. Anything can work in here, basically. You're either going to have, you could do 3 to the 1 times 3 to the negative 1. That's going to be 3 to the 0. You could do 3 to the 2 times 3 to the negative 2. Anything that you would add together would make 0, right? So the positive and the negative version of it. This one, lots of people had a correct answer here, but it didn't have the negative number, so it wasn't right. Because a lot of people put 2 here and 2 here, because 7 to the 4th or 7 to the 2 equals 7 to the 2. Yeah, that's right, but there's no negative number. So you could put in, let's say you do 7 to the 4th over 7 to the 5th. That's going to equal 7 to the negative 1. So there's your negative. There's not one right answer to this, except down here. These two, anything that would, as long as it works for the rule, it works. Down here, though, this is one thing that we touched on very briefly in class. Okay? So up here, the bases are all the same. That's why the rules for the exponents work. See how it's 3, 3, 3, 7, 7, 7? Well, this is 5 and 15. So either the bases need to be the same or the exponents need to be the same. So where the bases are not, they're not the same here, it means the exponents have to be the same. That means in here, this is going to be -5, okay? So we have 5 to the -5 times something to the -5 equals 15 to the -5. Well, that something has to be 5 times what equals 15? Well, that's 3. So 5 to the -5 times 3 to the -5 equals 15 to the -5. And I'm going to prove why that works down on number 20, okay? All right, 19. If you write 3 squared times 3 to the -6 equals 3 to the -4, Diego challenges you and says, prove it, but model why your answer is correct without referencing the exponent rules. Again, whoops, a bunch of you didn't read the instructions. You just said, well, you do 2 plus -3 and you get -4. Well, yeah, that's right, but you're using the exponent rule. So remember, when we break it down or we problem solve it out, 3 squared is 3 times 3. 3 to the -6 means you shoot these 6 down to the bottom. 3 times 3 times 3 times 3 times 3 times 3. Because remember, that means a fraction. This means 3 to the -6 means 1 over 3 to the 6th, right? So 1 over 3, 3, 3, 3, 3. Okay? So you cancel out what you can, and you're left with 1 over 3 to the 4th, which we know equals 3 to the -4th. This is how you prove it without using the exponent rules, okay? Now this one's a little trickier because we didn't really spend a lot of time on this one, but this is going to prove why 18 works, okay? So hang with me here. We've got 3 squared and 4 squared. So 3 times 3, 4 times 4 equals 12 times 12. Well, we have to prove this without referencing the exponent rules. Well, what can we do? Let's match up what we can right here. Okay? So let's do 3 times 4. That takes care of this one. And then 3 times 4 again. Okay? Well, what is 3 times 4? It's 12. So you have a 12 times 12, which equals 12 times 12, which equals 12 squared. Ta-da! So if your exponents are the same, then your bases can change, okay? If your bases are the same, then your exponents change. Hopefully this helps you on your study guide, and if you have questions on specific ones, please post on Google Classroom and let me know which number to redo for you, and I'll explain it a little bit further if needed, okay? Hope you are doing okay and staying healthy and doing your social distancing, and hopefully you're getting a little schoolwork in so your brains don't turn to mush. I miss you guys.